So the majority of semester 1 is going to be a lot of review from like Algebra 2, okay? And so if you were like real solid in Algebra 2 and you feel like you got it, no problem, you're going to be pretty good to go for this class for the first term, I'll say, for term 3, I guess. And then we'll start getting into some more new stuff in the 4th term and all that, okay? So first thing we're going to jump in with actually today is the distance and midpoint formulas. Bless you. Okay. And looking at those things. Both of these things you will have to memorize too. These will not be given to you on any sort of formula sheet, so you will want to have these memorized. Okay, for sure. Okay. And of course know how to use them too as well. Okay. So of course distance formula, we'll start with that one here. I'm going to start with like a little picture. Okay, we'll graph like the coordinate plane here, focusing on that first quadrant. And we'll pick 2 points here. I'll pick point like A, and then we'll put point B right there. And we want to find this distance from A to B. We want to know what is the distance there from A to B. Right? If it was horizontal, right, if it was completely flat, that distance wouldn't be that hard to do. You just count, the change in the x-coordinate. If it was completely vertical, if it was straight up and down, we could find the distance of that, no problem, just count, the change in the y-coordinates. But here when it's diagonal, it's a little bit harder because there's not really boxes that go in this direction, right? We have like the tick marks would go left, right, tick marks go up and down, but we don't have any like diagonal tick marks to get that length there. So we need something else, right? And so if you recall, if we give A some generic coordinates, and we'll give them the coordinates x1, comma, y1. Okay, I'll zoom in some more there for you. And we'll give B those similar generic coordinates, but we'll say x sub 2 and y sub 2, like that. Okay. So again, to find the distance between those things. Well, what we can do is, let's see here, if we kind of okay. So we draw some lines there from the different coordinates on our coordinate plane there. So this is like x1 right here, right? Because that's the x-coordinate of A at that point. And then here for B, right? This should then be x sub 2. Right, that coordinate there. And then the y-coordinates, well, this should be y1, and this should be y2. Again, for similar reasons, right? That's how we kind of designated them to be. And so then from this, we kind of create an intersection right here of these two pieces. Okay, we'll call this point C, just to kind of continue our alphabet there, I guess. Right, A, B, C. And the coordinates for C, we can actually come up with. For example, what is the x-coordinate of C going to be here? Anybody? What's the x-coordinate for C? Or what's like the thing that would represent the x-coordinate for C here? Yeah, x sub 2, that's right. Yeah, x sub 2, right? And then what's that matching y-coordinate? What would the y-coordinate there be? Anybody? Yeah. Y1, yeah, exactly right. Very good, yeah. Okay. I know it's like extra scary to like volunteer on the first day of class and it's like, well, what does he want us to do? And stuff like that. But that's fine. You can raise your hand, that's fine. If you want to just say it, that's fine too. Okay. Anyway, yes, x2, y1. Okay. All right. So how is that helpful? Right. Well, what kind of shape do we have right here? Okay. So it's a triangle. What kind of triangle though? What kind of triangle is that? What's special about that triangle? It is a what triangle? Right triangle, that's right. Okay, geometry, right? Okay. And so from that right triangle, if we want to find this right here, we have a way to relate the three sides of a right triangle, right? We have the Pythagorean theorem. And so we have that a squared plus b squared equals c squared. Okay. A and b, of course, are the legs, right? C is the hypotenuse. And so let's see here, okay? So one of the legs, this leg right here, well, we don't have a number. We don't have a value for this leg, but we do know that if this has x coordinate x1 and this has x coordinate x2, then this full length here will be the quantity x2 minus x1. Right? If this was like 2 and this was like 5, then the distance between the two would be 3, right? If this was 2 and then 5, the distance would be 3. And so we can just get that by subtracting. And then likewise, right, over here, same idea, we can do y2 minus y1. Okay, for that one. And so now we have something representing this leg, something representing this leg, and we want to find that hypotenuse. So let's plug it in here. So it's going to be x2 minus x1, quantity squared, plus y2 minus y1, quantity squared, equals, and then our distance there squared, so I'll just put that as like a capital D for distance. And then, of course, we square root both sides. I'm going to flip the distance around to the other side here. We square root both sides. Okay. All right. Technically here, we're in an equation setting. When we square root both sides in an equation, we should really have that plus or minus there with the square root. But, of course, since we're talking about distance, okay, since we're talking about distance, a negative square root wouldn't make any sense here. It would be a negative distance, which, negative distance should be positive, right? So yeah, so we want to keep just the positive square root there. And we'll worry more about the plus or minus square root stuff later. Okay. So for right now, boom, there's the distance formula. Okay, there it is. All right, so let's just do an example or two of these here. Yep, okay. So let's find the distance between A equal to 3, 0 and B equal to the 0.54. So now we have points, we have coordinates and stuff like that. Okay. So A, we can still call that, the x1, y1 if you want, right? And the B can still be x2, y2. As we had before. Doesn't really matter which one you designate to be which, right? B could be x1, y1, and A could be x2, y2. Doesn't matter. And so then we'll just use our distance formula here. Okay. So it's the square root of our x's, so 5 minus 3. And then y is 4 minus 0. So let's see here. 5 minus 3, that's going to be a 2 squared. 4 minus 0 is 4 squared. And then let's see, that's going to be 4 plus 16. Right, squaring the 4, 2 and squaring the 4. And then that, whoops, that's not a plus, that should be equals. And that's the square root of 20. Okay. And the directions aren't really specific here about, what to do. Should we simplify the square root? Shouldn't we simplify the square root? It doesn't really say. I'm going to go ahead and simplify the square root here just because, why not, right? Refresh that a little bit too in our mind. So square root of 20, right? There's a perfect square. We can divide that. That's equal to the square root of 4 times the square root of 5. And I chose the 4 there because that's a perfect square. So we get 2 times the square root of 5. Okay? And so there's our distance. There's our distance. All good on that? Pretty straightforward, easy stuff. Too easy, boring. Gotcha. All right. Moving on. Let's try another one here. Let's switch it up. Okay. Let's start with the distance between, whoops, I can't spell, the distance between A and B is 10. Given A has coordinates there, the -2, 3, and B has coordinates x, -3, find x. Find x. Okay, so distance between A and B is 10. Given that A has the coordinates -2, 3, and B has the coordinates x, -3, find x. Find x. So here's a bit of a twist, right? A bit of a twist. So, any ideas here about how to set this up? What should we do? How can we do this? Yes, Caleb? Okay, so where should these things go then? What goes where? Okay, so 10 equals, and then the square root, and then what are the x coordinates we're going to subtract? Okay, so you want to do the y coordinates first? That's okay. So I'll put that here at the end, but that's fine. Yeah. So -3 minus 3, we'll say there squared. Okay. And then what about the x coordinates here? So how you want to subtract those? I guess. Yeah, x minus the -2 there. Again, those are squared, just like that. Okay. Watch your signs, right? Easy to drop a negative here, something like that. Okay. x2 minus x1, y2 minus y1. You want to subtract the x coordinates, subtract the y coordinates. It actually doesn't matter the order here at all. You can even switch it up. You could change it. You could do, you know, like -2 minus x for the x's, but then you could do -3 minus 3 if you wanted to. It really won't matter because of the squares and stuff. Okay, great. And so, well, how should we proceed then from here, Kayla? Because we already have the distance, but what are we supposed to do then? What should we do next? So that's right. Good setup. That's what we want to do. That's how we can set that up for sure. Any ideas what to do from here, though? Okay, so you want to simplify the right-hand side here, something? Okay. So then -3 minus 3 is going to be -6. And then x minus -2, I don't like the minus negative. I'm going to make it plus positive. So it's x plus 2 squared. Okay. I want to pause here real quick. All right. One thing that I find students are tempted to do here, students are tempted to take this square root, all right, and break it up over addition. So sometimes I see students, they want to do this. They want to do like, okay, well that's equal to x plus 2 squared like that plus -6 squared like that. Okay. We can't do that. You can't break a square root up over addition or subtraction, right? So the square root of a sum is not equal to the sum of the individual square roots there. You can't break it up like that. Just the same thing with subtraction. If it was multiplication, right, if it was this thing times this thing, then absolutely you could break it up. But with addition, it won't work. It just won't work. All right, so anyway, it looks like we can continue here. X plus 2 squared. Okay, x plus 2 quantity squared, what's that going to equal? What does x plus 2 squared going to equal? Is that just x squared plus 4 like that? No, it's not. Okay, again, students tend to want to do that, right? You want to distribute the square to the x, distribute the square to the 2. But no, sadly it's not. Okay, x plus 2 squared, right? It's x plus 2 times x plus 2, right? You multiply that thing by itself. Okay, and so we get x squared plus 4x plus 4. Okay, so luckily I can fix this very easily like that. And then we still have the -6 squared, so it'll be plus 36. Okay, ooh, got some like terms there. Okay. All right, so we simplified Caleb, but now what? You're like, why am I still on the spot here? Okay, you don't have to. I mean, do you have any idea? How should we proceed from here? I simplified everything inside the square root, like you said we should. Now what, though? Any ideas? Okay. Okay, hey, that's fine, that's fine. You took us very far here, that's great, and that's okay. This is the point, you know, I just want to see where you guys are, what you think here. Any ideas? Can someone help us continue here? What should we do next to solve it? Yeah, go ahead, Nick, I guess. You prefer Nick? Okay.
Square both sides.
Square both sides, all right, we got the square root, we got the x's underneath the square root, we want to get the x's, we're trying to solve x, we got to get the x's by themselves. Let's square both sides here. Okay, square both sides. So we end up with 100 equals then the x squared plus 4x plus 40. Okay, Nick, do you want to continue? What should we do now?
Subtract the 40.
Subtract the 40 over. Okay. And then we get 60 equals x squared plus 4x, like that? Like that? And then what do you want to do?
I do it my own way. I don't know how to do it from here.
Okay, so you're telling so you you told me something different than what you did?
No, I solved it. I can't explain it. I just solved it.
Okay, that's fine. So you can't explain it. So what did you get for your solutions then?
I got x
And?
I only got one.
Ah, okay. So there's actually two solutions here, and x equals 6 is one of them though, so that's good. So I'm gonna go one thing here real quick, right? We're equal to 60. All right, some of us may be tempted to say, oh, then Mr. Whitmire, there's a GCF here. We can factor out that x, make it x plus 4 equals 60, right? But now we have a problem. Okay, you might be, what's the problem, Mr. Whit? X equals 60, x plus 4 equals 60, solve it. It doesn't work that way, okay? When we have two things that multiply to make 60, that does not mean that one of these two things has to be 60, right? For example, one could be 2 and one could be 30, right? One could be 4, one could be 15. There's only one number that if two things multiply to make that one number, okay, that means one of these two things has to be that number, okay? And that's 0, all right? I guess that was very maybe confusing the way I said that. But anyway, we have to equal 0 here. So what we should have done, and you guys are going to be mad, I know, but there it is, okay? So we actually want to subtract the 100 over, so this thing is equal to 0. And so we have 0 equals x squared plus 4x minus 60. That's what we want. Okay? We need to be equal to 0 here to be able to use that 0 product property. Only 0 has that special property that if two things multiply to make 0, one of those two things has to be 0. Okay. So now, man, this is a long problem, right? So how do we factor this? How does it factor? It's going to be x and x, right? So how does this thing factor? How does it factor? Yes, go ahead, Anna. Yes, minus 6 plus 10. Very good, exactly right. Lots of different little tricks that people use, you know, depending on how you want to do it. You know, I was taught like the guess and check method, where you basically just like, you know, you're like, okay, I got to make x squared. I know this needs to be x and this needs to be x. They need to multiply to make x squared. You know, I know I need to multiply to make negative 60 and add to make 4. So it's just like a matter of guessing and checking, you know, what that is. And for these kind of problems, that's kind of the best I could go with that. And you might have your own strategy, and I'll go over some more strategies later. But right now, that's what we got. And of course, we have two things then that multiply to make 0. So that means either x minus 6 equals 0 or x plus 10 equals 0. And so then x is 6, as Nick correctly identified there. But also x is equal to negative 10 is a solution as well. Okay, that would also work. It does work. Wow, so slight change in the problem, right? Still using that distance formula, but it required a lot more in-depth kind of mathematics here. All right, so, and I will do that from time to time. I, let people kind of like go a certain path or whatever, and I don't worry, I will stop us if it goes like too far, in a direction we don't want to go or something like that. But I hope that you won't take it as an insult that I let that happen, because chances are if you're making that mistake or if you're following that path, someone else is going to follow that path, and so it's a learning opportunity when we do these things, okay? It's teachable moments and stuff like that. So please, again, you know, please don't be insulted or anything like that, or like feel like, you know, embarrassed or anything like that. We all are going to make mistakes, okay, and that's going to happen, and we can learn from them, and that's the beauty of it. All right. So, yeah. Anyway, negative or positive 6 and negative 10 there. Okay. All right. Moving on. Let's look at the midpoint formula. I don't have anything so cool for the midpoint formula. It's, you know, or I guess quote unquote cool, because again, maybe none of this is cool. So the midpoint formula. Again, this will be you need to have it memorized. It's just the average of the x coordinates. It's like the mean or the average, right? x1 plus x2 over 2, and it's the average of the y coordinates. y1 plus y2 over 2. Okay. So yeah, that's it. I'll do a quick example here. And again, I don't have anything too exciting. Find the midpoint of A, which has coordinates 3, 0, and B, which has coordinates 5, 4. And the midpoint formula is kind of weird because you're not finding just a single value, right? Like the distance formula, it's distance is what you're trying to find, generally, right? You plug in 2 points, it spits out a number, the distance. Midpoint formula, you're really finding 2 things, right? You're finding an x-coordinate of the midpoint. The midpoint, its answer, its result, right, is a point. So you should have an x-coordinate and a y-coordinate. So we're going to plug in, you know, x1 plus x2, so it'll be 3 plus 5, all over 2. And then y1 plus y2, 0 plus 4, right, all over 2. And so, I don't even know if I should put an equal sign here. Maybe we'll just put an arrow. That's going to simplify to then, well, that's going to be 8 over 2, so 4. And 0 plus 4 is 4 over 2 is 2. And so there's our midpoint right there. Okay, no surprises there, just simplification stuff. Okay, questions on any of that? Alright, keep on chugging then. We're going to look at lines. Okay? We're going to look at some line stuff too. Okay? There's 2 main forms that I want us to be kind of familiar with. That's slope-intercept, which, you know, is very familiar, hopefully, to all of you. Okay? Slope-intercept form, which of course is the classic, you know, y equals mx plus b, where m is the slope and b is the y-intercept. Okay. But the other form that I want us to be really familiar with, that maybe, you know, you've had less opportunity to work with, is point slope. And this is one that definitely shows up. I know it showed up. That format showed up on the benchmark, the benchmark that we took just here at the end of, you know, my last pre-cal classes. So you should be familiar with it. It's so nice to know. And I can tell you also it'll be hugely useful if you plan on taking calculus too. Very useful to become familiar with point slope form. Okay. So point slope, just like slope intercept, their names describe kind of like what they are. So slope intercept form, okay, right? It's the equation of a line that with the slope kind of there and the y-intercept right there. And so when it's written that way, it graphs as a line, but it has those particular, you know, characteristics, right? Point slope form also is kind of named in a similar fashion, right? You can see right there, there's the m, right? There's that slope showing up. But instead of requiring a specific point, right? Slope intercept requires the specific point, the y-intercept of the line. Point slope form allows you to use any point on the line, any point, including the y-intercept. Okay, and so that the x1 and the y1, okay, are any point on the line. Oops, off the screen. There we go. Okay, so it's x1, y1 is any point on the line. Okay. So this makes things a lot nicer, a lot easier to calculate, because instead of needing a very specific point, the y-intercept, you can just use the point, any point, and that'll help you. All right. Other stuff that we need to like recall, remember, okay, And again, this shows up like, goodness, we were studying for the benchmark, and like this stuff was on that benchmark, if you can believe it or not. So like, here we are, day one, looking at stuff that I know was on the benchmark for, again, my last Precal class. So, you know, that's how, you know, I guess, cumulative that test is. Not to scare you, though, because, again, you can't cover everything in the benchmark. So parallel lines, right, they have the same slope. Perpendicular lines, and this is one of the questions that was showing up. I was talking about perpendicular lines. So two lines are perpendicular, and students ask because they forgot we hadn't practiced it in a while. So negative reciprocal, or sometimes you say opposite reciprocal, whatever you want to say there. So perpendicular lines, their slopes are opposite reciprocals, right? So for example, if you have one line with a slope of 1/2, then a perpendicular slope would be -2/1. So it's reciprocal, right? 1/2 becomes 2/1, and then if it's 1/2, it becomes -2. Maybe I should put opposite reciprocal, because negative indicates you just make it negative. Sorry, let me make that opposite reciprocal. That'll be good. Okay. And then, of course, there's some other slopey kind of stuff too. For example, if you have a horizontal, okay, a horizontal line, it has a slope of 0, right? And it's the equation for that is like y equals blank, where that's just like a number. This doesn't quite fit in the same vein as those parallel perpendicular stuff, I know, but still, it's like important stuff to remember, right? Likewise with vertical line. Okay, the slope is undefined. You know, a number over 0. And the equation for vertical line is x equals blank, where that blank is a number. Okay. Alright. So, here's one for you guys to try. I'm going to give you some stuff to try here. So with all that information now, what I'd like you guys to try here is to tell me whether the following are parallel, perpendicular, okay, or neither. Okay. So the next sets of lines here. So for this first set here, okay, x plus 3y equals 7, and 4x plus y equals 6. Okay, are those parallel, perpendicular, or neither? Go ahead, give those a try. All right. Next one here, 6x plus 4y equals 8, and 3x plus 2y equals 1. Again, parallel, perpendicular, or neither. You may need to rewrite them in slope-intercept form if you want to. And then the last one here, 12x plus 10y equals 32, and negative 6x minus 5y equals negative 16. Okay. So 1, 2, 3, parallel, perpendicular, or neither. Go ahead and give those a try there. I'll zoom in some more. Okay. Abby's going to come and give you guys another pre-cal book. No, you don't have to carry two. It's for you to put into your desk, please, and for the next class when they come in and stuff like that. So, please, please just take the book that she hands you and put it in your desk. Put that one in your desk for the next one. Oh, I'm sorry. I don't like to have to do something. I'll get in your way. We're not done yet, though, so please don't, turn off or anything like that. We're not let's see. Give you the try here. If you're stuck too, feel free to put your hands here. I'll come around and help get started at least. But again, 1, 2, and 3, try to identify. Are they parallel? Are they perpendicular? Are they neither? Yeah, so at this point, no, you're fine. At this point, with the way you have it divided here by 2, and you want to continue this here, so you can break up this fraction. So you make it 1/2 minus 3/2.
Yeah.
And then you can identify your slope. So that was the same thing here. You make it 4/2 minus 3/2.
I see.
So you break it up, and that'll give you what you're looking for.
Okay, thank you.
You're welcome. And then does that make sense? Yeah. Okay. Okay. Does anyone still need more time on this? Okay, I'll give you like 30 more seconds here, and then we'll move on. Well, we'll go over it and then move on. All right, so Daniel K. We actually have, I think we have 2 Daniels here, but Daniel K. Kabritsky there, number 1. What'd you get? Parallel, perpendicular, or neither? Not sure. Okay, so what do you think it is? You'd say neither. Okay, so if we look here, right, we take that x plus 3y. Did you put it in slope-intercept form? You just were looking at it and kind of were able to tell? All right, cool, very good, that works. I'm going to put it in slope-intercept form here just so we can see. So you subtract x from both sides here, we get 7 minus x on this side. Okay, divide both sides by 3, we get y then equals, so dividing through by 3, you can divide the entire side or you can divide just each piece on that side by 3. So anyway, we get 7/3 there, minus, and then, well, there's a 1 here, so minus 1/3 x. Okay, but then if we do the second equation here, it's y. If we subtract 4x from both sides, we'll get 6 minus 4x, and so we can clearly see here the slopes, they're not the same, right? They're not opposite reciprocals, and so yeah, the option here is neither. They are neither parallel nor perpendicular. So very good there, James. Thank you, sir. All right, let's go to Kayla. Your number's up again. All right, or your number's up this time. So what'd you say for this one, Kayla? You got perpendicular. Okay, so did you do the same thing? You put it in slope-intercept form. Okay, so let's do that here real quick. For that first one, it'll be 4y equals 8 minus 6x. Divide through by 4, you get 2 minus 6 over 4 simplifies to 3 halves. And then here, we'll get 2y equals 1 minus 3x. Divide through by 2, we get 1 half minus 3 halves x. So it looks like the slopes are, in fact, the same. So we want to say perpendicular. They are parallel. Did you have a question on that one, Kayla? You okay with what? Did you see what you did there? Okay. So then 1, neither. 2, parallel. So 3, right? We can just go ahead and just say this one's going to be perpendicular because I gave you 3 options and there are 3 problems. So it's going to be perpendicular, right? No, they're not perpendicular. They're not. Okay, so don't, that's good logic. I get what you're saying, right? Every other math teacher, or maybe, that's the way it is, right? There's 3 questions, there's 3 options. Certainly each one will be an example. But no, in this case, that's not the case, right? If we solve here for this first one, we get 10y equals 32. Well, actually, I'm going to go ahead and ask you guys. So if it's not perpendicular, what is the answer here? Anyone want to say? Parallel. Parallel. Okay, I hear parallel. Do we all agree with parallel then? I see a head shaking yes. I see a head shaking no. Anyone want to say something else then besides parallel? Neither. All right, well, let's just see. We have disagreement. 32, subtract the 12x from both sides there. Divide through by 10. So we get 32 tenths minus 12 tenths x, and yeah, I can simplify that. We'll come back to that and simplify it later. All right, add the 6x over negative 5y equals negative 16 plus 6x divide through by the negative 5. We'll get 16 over 5 plus negative 6 over 5x. All right, well, like I said, I can simplify this. So 32 tenths, that simplifies to 16 fifths. 12 tenths simplifies to 6 fifths x, and oh my gosh, they're the same line. Okay, so this is partially my fault, right? When I told you guys parallel lines, I said they had the same slope. And while that's true, they need to have the same slope, but they need to also be different lines. So, for example, they need to have different y-intercepts. Okay, if they have the same slope and the same y-intercept, but the same line. So, same line. So, yeah, the answer here is really neither. Neither. Okay. So, all right. Okay, so that's the idea. All right, I have one more thing I want to show you. We're not done. Oh, Mr. Witt, you're the cruelest. I know, you're the worst. It's making us go all the way up to the bell here. I'm going to blame it on the fact that we had to go over the syllabus and stuff, though. I mean, that's what I'm going to choose to blame it on, and not that I'm trying to squeeze too much in to the first day. All right, last thing here we're going to look at is writing the equations of lines, because it's going to be on the assignment, and I want to make sure that you're good to go on that. All right, write the equation of the line given. Okay. Write the equation of the line given 1. The slope is negative 3. And it goes through the point 3, 1. Okay. Negative 3 and goes to the point 3, 1. All right, and again, just for the sake of time, I'm just going to run us through these here because I want to make sure we get through these. All right, so I'm going to guess that most of us are familiar with or comfortable with that slope-intercept form. So y equals mx plus b. Then m is negative 3, so you can say negative 3x plus b. Okay, and then I want to, well, that's not quite an equation, right? I still have to find that y-intercept because, we can't write the equation along without that y-intercept there. So we can plug this point, right, 3, 1. If our line goes through that, that means that point must work in the line here. So the 1 is the y-coordinate, we'll put it in for y. And then the 3 is the x-coordinate, we put in for x. and solve for b, so that's going to be negative 9 plus b. We add 9 to both sides, you get 10 is b, and so the equation is negative 3x plus 10. Alright. Man, it stinks that we have to find that y-intercept. If we didn't have to find the y-intercept, you know, because we already have the slope, we'd be done. And in fact, we don't need to find the y-intercept, right? Because we have point slope form. Y minus y1 equals m times x minus x1. Okay. Do we have a point? Yes. Do we have a slope? Yes. Then we're done. Okay. Y minus 1 equals the slope, negative 3 times x minus 3. And there's your answer. Okay. This is me trying to sell you on the idea of getting down that point slope form. Either answer is acceptable. You may choose to go either way. You want to become familiar with point slope form, though. If you're like bread and butter to slope intercept form, you need to become familiar with point slope as well. All right. All right, we're gonna do another one here. All right. And this will be the last one, I think. Well, maybe not. We'll see. All right. Through negative 2, 6, and 4, 9. Okay, so now our second line here, we want to go through 2 points, negative 2, 6, and 4, 9. Okay, negative 2, 6, and 4, 9. So, what do we need to find now to write the equation of this line? First thing we should find is the what? Slope, right, and then we can either find the y-intercept or use point slope form. So, the slope then, right, y2 minus y1 over x2 minus x1. 9 minus 6 is 3, 4 minus negative 2 is 6, so it's 1/2. I'm going to skip slope intercept form. I'm assuming most of you guys know how to use it, right? I'm just going to do point slope form because it's so darn easy. And there it is. Okay, no need to find a y-intercept. You can use either point there, and you're done. Okay, another one. Write the equation of a line parallel to y equals 2x minus 4 through the point 5, 7. Okay, so we write the equation of a line parallel to that line through the point 5, 7. Psh, easy. What's the slope of our line got to be? 2, right? If the slope of that line is 2, we're parallel, same slope. So, again, I'm going to use point slope form because it's just so easy. Don't have to find the y-intercept. There it is, x minus 5. Boom, done. Last one. Then we're really done at this one. Perpendicular to y equals 2x minus 4 through that same point, 5, 7. Okay? So what's the slope for our line got to be? Negative 1/2. So y minus 7 equals negative 1/2 times x minus 5. That's all you got to do. Just change the slope. Again, point stayed the same. Okay, so it's just point slope form there. So easy. So easy. Okay. Whew. We made it. All right, let me give you guys your assignment. Oops, that's not the assignment. This is. It's going to be out of the book. Page 9. There's also going to be some solving systems of equations there, right? Where you have 2 equations, you want to solve them, get the answer, you know, where they intersect and stuff like that. You can choose to use substitution, elimination, or graphing there. We have to do 48 to 58, the evens on page 9, page 34, 57 to 71, and then 79 to 83. That's just the odds for that. And then one more here, page 501, numbers 21 and 29. Okay. There. I'll go stop my video.